Hi everyone. It's just gone 10, 12 o'clock, so we will start now. I think we might have a few late arrivals. We'll just let them just join the meeting now. So firstly, thank you all for joining the third webinar in the Resilient Cities webinar series. I'm Kirsten Johansson, Chair of the Resilient Cities group. Can I please ask if you could please mute your microphone if it isn't already? So that we can begin with the first presentation. Today's topic is on master planning and urban design, and we have three presentations. We have Guneet Kohli of Arup talking on surface albedo and solutions to government. We have Julie Future of Climate 22 talking on climate responsiveness, urbanism. And we have Alex Towler from Transition by Design talking on urban resilience, who defines it, who designs it, and who pays for it. If you do have any questions, please feel free to pop these into the chat window and we will either address these at the end of the presentation or at the end of the webinar. So without further ado, I will hand over to our first speaker, Guneet Kohli of Arup.
Thank you. We'll just share my slides. There we go. Has that come up okay? I'm guessing everyone can see the slides. Yeah, great, thank you. So hi everybody, and thank you very much for joining today. Today's first presentation is on surface albedo and looking at identifying high-risk areas and also solutions to decision makers like government. I hope today's talk demonstrates how changes to our built environment through albedo strategies in particular can be an effective response and mitigation measure to our rising temperatures and climate emergency. So just to introduce myself, my name's Guneet Kohli. I'm an engineer at Arup based in London. I'm an environmental physics engineer, but also work a lot in the climate space and bringing these two fields together. So this is through my expertise in climate change projections data and increasingly looking at solutions to climate change like albedo strategies. So today's talk has three main areas. The first is just a brief introduction into what is albedo. The second then looks at this on a building scale and specifically through our work with the Million Cool Roofs Challenge. And then the third part of the talk looks at this on sort of a city scale with the Arup albedo tool. So to start off with, what is albedo? Last month's webinar, there was a great presentation on urban albedo, and it was really fascinating. This month's talk is specifically about surface albedo, so I'll be talking a lot more about roofs. But to start off with, introducing albedo. Albedo is a measurement of the surface reflectivity. So ice has a very high albedo of about 0.9, meaning that it reflects a lot of the sun's energy, whereas concrete and asphalt have a low albedo of around 0.3, meaning it absorbs a lot of the sun's energy, which lands on its surface. With our increasing temperatures, our melting ice caps, the overall albedo of the Earth is decreasing, meaning less reflectivity of the sun's rays back into the atmosphere and a greater warming effect. Many die every year from overheating, particularly in less developed countries where mechanical conditioning just isn't feasible. And a simple solution to this lies in our urban environment and choosing materials that will increase reflectivity, like white roofs and white roads. With the incorporation of lighter aggregates and cements, concrete can gain an albedo such as 0.7. And in Arup, we've been looking at this on a building scale and a city scale and how we can best present these albedo solutions to decision makers. So starting on a building scale, we're currently working with home building NGOs to install high albedo surfaces by painting these surfaces white on buildings they construct. So particularly the roofs, but also the walls too. With our climate emergency and increasing temperatures, there's an estimated 1.1 billion people facing access to cooling. This includes 630 million slum dwellers living in hotter climate urban areas where electricity services don't exist, are very intermittent, or just too expensive. The Million Cool Roofs Challenge is an organisation involved in implementing high albedo strategies worldwide. And Arup have partnered with HLA and New Story, who were involved in the construction of building homes for families who are living in extreme poverty, often living in dangerous and rickety makeshift shelters. So the image on the left is an example of one of the houses constructed, and this is a 3D printed version, and the one on the right is constructed with more traditional methods. So we've been doing modelling to look at the effect of painting these roofs white for these houses, which increases the albedo and reflectivity, and how effective that can be as a passive cooling strategy, as mechanical cooling isn't feasible for these houses. So our case study here is in Villahermosa, which is in the Tabasco region of Mexico. And overheating is a problem here, and we can see by the temperatures on the right that they reach over 30 degrees pretty much throughout the year. So we've been using the Arup software Beans, which is part of the Oasis suite of softwares, to do this thermal modelling and the effect of looking at these different albedo roofs. So the floor plan on the left is a typical floor plan for these houses. They usually have 2 bedrooms, a bathroom, a living room, kitchen, and also a front and rear sort of veranda area. And our study looked at a base case where the unpainted roof has an albedo of about 0.3, and then we also looked at some high albedo paints on the roof. It's worth saying that here the roof is flat, which is sort of advantageous for reflectivity, but also when talking to the families that will live in these houses, they were really keen on flat roofs as well, so that they could potentially build a second story if possible in the future. So this graph kind of gives a snapshot of the results of this study, and it looks at operative temperatures inside the house as a measure of the thermal comfort inside the house. We have the base case in purple, which has the low albedo of 0.3, so the roof is unpainted. And then we have 3 different albedo paints of 0.75, which is the red, 0.85 the yellow, and 0.95 the green line. And here we can see it's a really effective strategy at reducing the internal operative temperatures inside the house by as much as up to 2 degrees by just simply painting the roof of the house white. We also took one of the cases, so we took the middle case, which was the albedo paint of 0.85, and tested this by also painting the walls white in our model. And here we see even more reduction in internal operative temperatures. So these albedo strategies have been recommended to HLA and New Story. It's also worth noting here that the whole study looked at also other passive strategies like blinds and glazing and the properties of windows, insulating materials, and the effect of these ventilation portals here. And a combination of strategies was the final recommendation. But actually, when we looked at each strategy individually, the albedo roof was found to be the most effective at in reducing internal operative temperatures. So albedo is a recommendation. It's a low-cost passive strategy at improving the thermal comfort of the houses, and we looked at this with modelling and operative temperatures. But to help us further talk to our partners and highlight the benefits of this, we're doing further research to quantify this in other effects other than operative temperatures. So this is ongoing work, but initial studies estimate that when compared to cooling with mechanical equipment, we see about a 50 kilowatt hour savings across the whole month, which is about $5, which is a cost saving for the families, but also the energy savings are quite substantial, as this is just one roof at 50 meters squared. So you can imagine worldwide, albedo strategies could have an impact on our global energy spend and thus our CO2 emissions. Finally, for this section of the talk, I just wanted to highlight that these strategies aren't just being used in Mexico with the Million Cool Roofs project, but are also already being seen all around the world. So this is the New York City Cool Roofs project, which has been ongoing since 2009 and has painted over 10 million square feet of roofs white. It's specifically targeted at vulnerable areas to overheating and is focused on energy savings for the buildings, and it's free for low-income families and schools, hospitals, universities, which leads me nicely into the latter half of the presentation, which looks at albedo on a city scale. So this is developing work in Arup, and we're using digital solutions to look at albedo on a city scale. So to start with, we know our cities are growing, and as they grow, our urban albedo is decreasing. So Houston, shown here, is one of the fastest growing cities in the US in terms of population and development, and is catching up to Chicago to be the third largest city in the US. So this image shown here is a map of urban settlement and how it's growing since 1975. So in Arup, we're working with satellite imagery, land classification, and machine learning techniques to map the albedo of cities and the contributions of albedo. So this example here is Houston, and the albedo is broken up in classifications in this example pie chart. By understanding a city's makeup, we can think about the contribution and potential mitigation to overheating through albedo. It can be useful as give us insights into what neighbourhoods are more vulnerable to heat through albedo makeup and help us plan albedo strategies like the implementation of white roofs and roads in refurbishment and planning. It also links strongly with urban heat island effect, as a collection of white roofs is just one strategy that can be considered as a mitigation measure. Furthermore, with increased reflectivity and less energy absorbed by the material, like a road, for example, the material's longevity can be increased. So it's really part of a holistic approach. This visual and interactive tool can be applied to any worldwide location and helps decision makers, such as councils and governments, really drive policy and planning. And with the quantitative picture into albedo, we're aiming to further develop the tool with more quantitative analysis, like cost and energy savings, as we're doing with the Cool Roofs project on a building scale. So I hope you've enjoyed today's talk, and I've demonstrated how high albedo surfaces are a sustainable option for overheating and our climate emergency. I just wanted to end on this article because I find it really interesting, and I think it's a great example of cities taking up albedo strategies. So the article here is by the New York Times, and it shows the link of albedo to temperatures quite clearly in these two images. So redlined areas in the 1930s were marked as risky investments, as were predominantly where Black families lived, and they had less funding from government, less green space, and more paved surfaces which absorb heat. These areas now exhibit higher temperatures than the city average, and the city shown here is Richmond, which is now developing a long-term master plan with government, looking at increasing tree canopy and also reducing the number of paved lots, as well as using lighter coloured pavement in refurbishments. So thank you everybody for listening. That's a wrap up of my talk, and I'd be happy to answer any questions.
Great, thank you very much, Gani. There's been some good conversation in the chat window here. If anybody wants to raise their hand and ask a question, please do, because we do have some time for questions. Just looking through the chat window, Chris Twin, if you'd like to unmute your mic, please feel free to ask your question.
Hi.
Or I can go ahead. Yep.
Hi, can you hear me?
Yes.
Right. Thank you for the good overview. My question was, the analysis seems to be looking at largely uninsulated or poorly insulated roofs, but presumably if you've got a good insulated roofs, you come from Northern Europe and what have you, the benefits are far less? And has that been looked at? And then a follow-up, how do you keep them clean?
Great. I'll start with the first question, and you're right. So this study has initially looked at sort of roofs that are fairly poorly insulated, and that's related to the construction of the houses, and is definitely a point that we're considering as we are looking at more case studies with houses all around the world and different makeup of houses. So thank you for bringing that up. The second question about sort of how do you keep up this was a reason why we looked at different albedos, because we understand that whilst you might paint a surface white, it degrades over time. And that's something that we've discussed with Echele and News Story, which is why we looked at different albedos, and also thinking about how often we might need to repaint the roofs on the low-cost housing.
Great, thank you, Gani, answering the question. Hope this is the question for you, Chris. Just moving on to another question here from Derek. Have you used titanium paints, which reflect 95 to 98% of solar heat?
Thanks, Derek. I don't believe that in the case study I've presented it was a titanium paint. It was sort of a low-cost, I'm trying to remember the name, vinyl Cormex paint, which was sort of the affordable option for the partners that we were working with in building the houses. But that is great that there's paints out there that have an even higher albedo than the ones that I've presented.
Okay, excellent. Thank you, Gani. We'll just move on to one more question, and then we'll move on to the next presentation. So from the Building Simulation Group, Darren Wolf, I believe. If you'd like to unmute or go ahead and read your question.
Thanks, Kurt. I've just got a couple of points I've actually been making. One is, I know we're talking about cool roofs, but quite often cool roofs are green. Mm-hmm. And I don't think we understand so much about the impact of photosynthesis, how much that takes out of the absorbed component of our solar radiation. And secondly, when we also talk about surface albedo, what's interesting is its impact on urban heat island effect and the onward impact on our local air intake temperatures and ability to naturally ventilate, perhaps where we might not have been able to otherwise. So it'd be interesting to hear your thoughts on that.
Yeah, so for the first point, which is about photosynthesis, you're right. It's sort of, I think albedo roofs sort of is part of the whole package of mitigating against urban heat island effect and green roofs. And green roofs sort of come as a sort of slightly different aspect than comparing it against concrete, because as you're right, green roofs absorb and reflect energy in a different way, like evapotranspiration, which is not quite fully understood and have been modelled yet. I think that is why at Arup we're looking at this albedo in sort of a whole holistic approach to mitigation, especially on a city scale. And I think albedo is something that I like to call like the low-hanging fruit in this sort of work, because it is quite a simple solution, fairly low cost for cities and buildings to incorporate at this time. So I hope that answers your first question. But yeah, I think it's definitely something that is ongoing research and really interesting to sort of know more about green roofs. And sorry, could you repeat your second question again? Apologies.
Yeah, so my second question was that there was some earlier questions about insulation and cool roofs, and I was making an observation that the overall assessment also needs to look at the local air temperatures above the roof and how that may impact your air intake temperatures or ability to naturally ventilate if you haven't got a mechanical system.
Yeah, Great. So the study that I presented below included sort of the ventilation portals for to kind of simulate natural ventilation through these houses, as that's really important because there is no mechanical cooling in the house. But with the sort of air temperatures above the roof, that's a really interesting point, and it would be great to get sort of incorporate that in our simulation, or on the city scale, sort of get more data about that and really have a data-driven approach to looking at sort of these albedo maps and layering this on with other data sets out there to really understand that relationship. And thanks everybody else for your questions. If you'd like to get in touch, I'd be more than happy to answer more questions.
Great, thank you so much, Gunit. Yeah, there's lots of questions there, which unfortunately we don't have time at the moment to ask. If we do have some time at the end, we can go back over these. Thank you very much, Gunit, and for those joining us midway through, the recording and the presentation will be available online. Thanks. So we're now moving on to our second speaker of the day. So this will be Julie Future of Climate 22, talk on climate responsive urbanism.
Hi everybody, can you hear me okay?
Yes,
Great
yeah, we can hear you and see your slide.
Great. So my name is Julie Futcher. I'm an architect, and since 2007 I've been working with urban climatologists trying to identify aspects of towards climate responsive urbanism. So we've been looking at this as an interdependent, the interdependent relationships from an interdisciplinary perspective. First of all, we identified the challenges, which most of us know, associated around urbanism, where we consider the conflict between increasing urban density and access to passive resources. And, of course, the changes in background conditions as a result of climate change, resource depletion, and energy management, building energy management. So, most of us live in urban environments, yet most of what we do is focus on the standalone building, which is really quite limiting. And we've looked at this through a series of studies in and around the City of London. Most of this research has been published and is available in a range of articles, both scientific and trade. If you contact me, I'm quite happy to send on that information. But we've clearly demonstrated that the envelope of the building extends beyond, the boundary of the building extends beyond its envelope and into the wider area. And this needs to be considered. We need to consider the net effects of our approach towards urban development. We focus on the City of London for a couple of reasons, partly because it has a really interesting day-to-day profile. It has or up until recently, it had a daytime activity level, Monday to Friday, 9 to 5. It was quite empty at weekends. It has around 500,000 people occupying quite a small space during the day, and during the evenings and weekends, it's quite empty. It also sits right at the very centre of London, so any activity that's happening, depending on the direction of the wind, is likely to encounter the City of London. Here's an image of the density of Greater London. We can see that the black spaces represent open space, not green space, but open space. And open space is really important, regardless of whether it's hard or not, to allow heat to escape. When we focus on the urban heat island, we often think about this as a negative effect. But what we must remember, in cities like London, more people suffer from cold-related issues rather than heat-related issues. So we really need to be mindful here and focus on the overheating effects of urbanisation. We also need to be mindful as well about the level of water that's in the surfaces and the effect that they can have on urban performance. Having an open space or an open green space might not be enough. This image here shows London's local climate zones. This is part of a global project that we're involved in, Gerald and I are involved in, which looks at the surface cover of areas of around 250 to 500 metres. So we can assess their intra-urban climate effects. That's the local built form outcomes that can be used to offset many of the wider issues that we face when we look at images, when we focus on the urban climate at the urban scale. For example, the urban heat island. These areas here represent Heathrow. We can see that this is quite a vast area. Richmond Park, Hyde Park and the City of London. Hyde Park and the City of London are relatively similar in size, as are Heathrow and Richmond Park. But we can see here that their colour, that their temperature difference is there's quite a difference there. You can see this is the edge of the city, where the temperatures are quite reasonable, but still lower than what we find in the inner city areas. And when we have parks such as Hyde Park here, there doesn't seem to be much of a difference at all in air temperatures compared to the surrounding area. That's because we're looking at the accumulated effects rather than just the actual intra-urban effects. So we've been exploring these outcomes in more detail. I've just put this slide up here because this is quite a good example of how confusing a lot of the information is out there. Both of these graphs tell us the air temperature differences between central urban London and a site outside of London. This one here shows us the temperature difference between the 3 zones in London compared to a rural location. This one here shows us the temperatures in the 3 zones, central, semi and outer. But from Heathrow, the temperatures are the same in both sites, but we can see that depending on where we look at, where we're comparing, we can see there's quite a big difference in these outcomes. This is as a result of the underlying surface. But what we're focusing in on here is the built form effect. So how the development of the urban area, the size of the buildings, the streets, the width of the streets, and how they can have a really impactful outcome on both the building energy management and the climate. So it is that relationship between the two. We know that built form drives urban climates, but it's not considered as an energy management parameter. We focus on our built forms driven on the historic footprint. Here we can see London, medieval London. We can still see some of the streets. Once the building footprint or the urban footprint is in place, it's quite difficult to change it. Even when it comes to installing massive infrastructure projects, such as we have here, the Crossrail link, it still has to wind its way through what's going on underground as well as what's going out on above ground. So we have quite a complex arena that we have to deal with. So it's almost that built form gets shoved out. We have to think about conservation as well, what the existing environment looks like determines our building heights, and technology as well, how technology has changed the built form. The buildings that this building replaced felt that they were no longer appropriate for the use of technology that we have today. There's another story hidden in here, but which we don't have time for. Easements as well is quite an interesting one as well. The reason why this building is this shape is so it doesn't interfere with views of St. Paul's, but we have similar effects on rights of light as well. This controls built form. This was an expensive modification to make to that building form. It wasn't so it looked quirky, even though the effects of this are not quite known. How far-reaching the effects of this built form on the wider environment is something that we really need to start to explore. Economics is another driver of built form, as is function as well. We have here the Art Gallery and the Tate Modern. They're more or less the same size in terms of footprint, but the way the surface are dealt with are quite different. And energy. This is my friend Sam. He stood at the bottom of the 20 Fenchurch Street. And we could see that the form of that building, 20 Fenchurch Street, the walkie-talkie, was quite powerful. Here's his shadow from the sun, and here's the shadow from the curved surface. And this is after they've made the modifications to the surface to stop the area from overheating. These built form effects are quite powerful, even though this is quite a giant of a building. So to explore this, we've been focusing on the Eastern Cluster, which, as you can see from this map, is right in the very central urban area. It's a lot denser than the surroundings. Here we can see it's quite lowing, where we have this kind of cluster, this mountain cluster. But what we want to know is the effect of this building group more impactful on the urban heat island than maybe a park? We talk about removing the urban heat island, but actually maybe what we want to do is optimize the outcomes of these climate effects. We need to understand that it's the surfaces, their proximity to each other that manage these effects. Height to width ratio is a prime example that we like to use quite a lot. I know I'm running out of time. So what we've done is we have been monitoring the city for a couple of years with the City of London. This project is nearly coming to an end, and we're looking for some more opportunities here, where we measured the air temperatures. And we can see that around the tall buildings, for example, around the Eastern Cluster, the air temperatures are always lower, which means that these taller buildings are having an impact on air temperature. They're bringing in what we assume that they're doing is bringing in the cooler air from above the canopy top into the streets and allowing these streets to be vented. We looked at that in terms of wind as well, and here you can see around 20 Fenchurch Street. In the winter, there is quite a dynamic range of wind speed. Obviously, this is not comfortable, and you could not necessarily sit down and have a cup of tea there. But maybe these buildings actually provide us with an opportunity that might be useful in terms of managing our climate at street level, as well as the building's own energy management. We've run a series of air quality tests on these sites as well, and our results were quite surprising. This graph here, red is no, yellow is okay, and black is we're in big trouble, is the air quality along Moorgate here and along Bishopsgate. Despite the levels of traffic at each of these sites, we know that Bishopsgate has a lot higher levels of traffic. It's a lot more congested than Moorgate. We find that actually there's not too much difference in the air quality. But what we are suggesting here is that its uniform form of Moorgate is actually containing any of the pollutants that are released there, where Bishopsgate, with its difference in building heights and street widths, are actually having a much more dynamic effect and helping to vent out a lot of the pollution. This black area here, we found a very dangerous spot, which was underneath a canopy, a temporary canopy, which draws questions around the suitability of overhanging canopies for shading, which pedestrians actually trapping pollution. But we know that air quality is an issue that's on the which we're improving. But there are other issues as well. It's not just about the air quality. This is interesting too. This here, we're looking at the Eastern Cluster, and we can see that this green is good. And a lot of the air quality around the Eastern Cluster demonstrates that we have quite good air quality. Again, at the 20 Fenchurch Street, we also have quite good air quality. And this fits on to some other research that we've been carrying out as well. And we have found that if you have a series of tall buildings and relatively low levels of traffic, we have quite good air quality. Having tall buildings on by themselves is not enough, and having low levels of traffic as well are not enough. It seems to be that these tall buildings address to some extent the accumulated effects that the City of London are experiencing. This is our verification model that I'm more than happy to talk to anybody about, which shows that our readings were quite matched quite nicely to a CFD model. And here we can see this green for go again at the base of the tall building, and you can see how the tall building is helping to flush this cool, cleaner air down here. We don't know if this is just moving on the problem, if it's putting it somewhere else, or if it's actually helping to remove it completely. We need to have a lot more work done. So why this is important? London's actually undergoing a change to its morphology, which will have long-term effects. Currently, there are 525 buildings planned of 20 stories or greater that's going to exist in Greater London. We don't really know enough about the impact of these buildings, good and bad, on their wider environment. We go back to that question, where does the boundary of the building lie? And we've also identified a need for a new accredited built environment discipline, which is something that we're working on. We can no longer deal with these significant challenges as independent disciplines. We're addressing all of this through a series of urban climate responsive events with the EDGE, which are kind of about to re-emerge. So that's everything. Thank you very much.
Fab, thank you so much. If anybody has any questions, please feel free to raise their hand, as we do have a little bit of time, or please pop these into the chat window. Just one question, Julie. You've done some really good research on the air quality, and have there been any kind of suggested remedials to overcome the bad polluted areas of London?
Well, there's some interesting ideas going on at the moment, but I think this just feeds into the bigger picture, really. I think the city is working very hard on trying to reduce its some of the issues. But as we know, this is all just changed now, and we've been measuring through the pandemic the air quality, and we're just about to start analysing that, so we can see how the impact of low levels of traffic on the environment too. But this project's just about to come to an end. We've got lots of research that we're in the process of analysing and writing up, and we're looking for the next steps on that.
Okay, excellent, thank you. We do have a question from Jeff. Jeff, would you like to unmute your microphone?
Oh, thank you very much, Julie. Very interesting presentation.
Jeff.
Hello. Do you have any index for the ventilation? Because I think some Swedish researchers have actually looked at the built form and actually come up with indices of the amount of ventilation in streets. I just wondered if that could be quite interesting to look at your areas of London, the actual ventilation indices.
Yeah, well, we've been looking at height to width ratio, so it's not just around those dramatic buildings. It's been just ordinary streets, and we found that there is definitely a relationship with height to width ratio and orientation to the wind, and what we've also started to observe, because we're measuring wind speed as well and temperature too, we've started to observe that some of these new buildings that are going up are actually completely changing the flow, the airflow through streets. So although those indices are in place, they can be offset, or any outcomes can be offset by an intervention. And built form is, I mean, maybe we could use sails, you know, on top of the buildings to redirect air through, or we could start putting up solar chimneys and start really, you know, let's mess around with it doesn't have to be tall buildings, maybe have a no-go zone by them or something like that. But, you know, we need to be more inventive here with our solutions. It's heat as well as, anyway, Jeff, you're always welcome to come on the Urban Climate Walk. I'd love to catch up and
Yeah.
Do that with you.
Outside COVID times. But there's a lot of turbulence in the canyons, though.
Sorry?
There's a lot of turbulence in the canyons. You can't, so that upsets the indices.
Yeah.
Yeah. Thank you.
Thank you.
Thank you, Jeff. We'll just end there, Julie, on it's Simon Rees. He's said very interesting, thank you. Where can further details of the project and publications be found?
Sorry, were you asking me a question?
Yes. Do you have any further details? The details of the project.
A lot of my can be found on ResearchGate. A lot of it can be found on ResearchGate quite easily, or just email me, and I'm happy to talk to you about that.
Okay.
Great, thank you. Bye.
Okay, great. Thank you very much, Julie. Okay, we'll now move on to our final talk. So Alex Towler from Transition by Design, who'll be talking on urban resilience. Alex, are you there?
Hello, everyone.
Great. Welcome.
I'll ask the mandatory question. Can you hear me?
We can hear you.
And also, can you see my screen okay?
Yeah, fab. We can see it. Great.
Okay. Wonderful. Well, welcome everyone, and thank you to the previous speakers and also CIBSE Resilient Cities group for organising this and giving me the chance to speak. Quite pleased, it's been two unsurprisingly quite techie, quite kind of engineering-based projects before this. I used to be the only architect in a building services office, so I'm quite used to being out of my depth with people. The title today is really looking much more of a social aspect of it, so it's looking about resilience and participative urbanism with the subtext of who defines it, who designs it, and who pays for it. So very briefly, Transition by Design is a design cooperative operating at the junction between architecture, strategic design, and social change practice. My name is Alex Towler. I'm the lead architect at Transition by Design. I previously also worked, following a master's in development emergency practice, worked as a humanitarian consultant, and very topically for this, I'm co-teaching a postgraduate unit in architecture around resilience by design. So this is an image of Nudgehot where we're working this year. So in this overview, there's a sort of underlying question that I want to look at. I want to do a quick overview of the critiques of resilience. So this is actually, I want to challenge resilience, a working definition of participative design, some case studies by my office, and some brief conclusions. So the talk is, can participative design improve the outcomes of resilience building projects and go some way to addressing their critiques? So I don't know if anyone has seen this poster before. This is from New Orleans in a response following Hurricane Katrina. Stop calling me resilient, because every time you say, oh, they're resilient, that means you can do something else to me. I am not resilient. So, you know, we're talking a lot about resilience. That term over the last decade has really come to prominence. However, it's really when you see that you've got kind of a grass level response against this term, there are some critiques going, there's something that really needs to be looked at this. Resilience is one of these kind of mother words, a bit like sustainability, community, which we assume to be good by default. So we need to look at some of those critiques of it. So I'm making sure I don't go overly academic here. So I've taken some of the academic distinctions here and tried to boil them down and make them a bit more accessible. So when it comes to who defines it, again, it's about actually understanding whose resilience counts in this situation. One of the most recent changes to the term has been, rather than bouncing back, a question of leaping forward, which then of course opens up the question, where forward to where? It then also opens up, which starts picking into the kind of interdependent one, which is act as an agency. So who designs it? Therefore, if you are unable to So the people who are most affected sometimes by this are the least involved in the process. So when we're talking about who leaps forward, who's forward, who are the people actually deciding what that forward is? And then the third one, which kind of plays into that, who pays for it, this isn't so much talking about who pays for a project in terms of project costs, but rather talking about who picks up the costs of resilience. So in some situations, people are paying for resilience. The resilience of one system can have a negative effect of the resilience in a secondary system. So some very kind of quick examples of that. Already touched on Hurricane Katrina. The idea about building back was strongly questioned, because if building back with a situation was already undesirable, we shouldn't be going there. But which way is forward? And as some of that kind of poster campaign said, there was a perhaps unfair distribution of costs. The resilience of the financial system was proven actually to be very strong following the 2008 financial crash. But involving that in getting the resilience back onto that system, there was a side cost here in terms of the social costs of austerity. So an image here with anti-austerity protest. And very contemporary at the moment, we're talking about the phrase "build back better" is being put around, and we're going to see in real time some of the already kind of debate about who's better, how are we going to do this, and unless there is more effective tools, it may mean that actually we're not building back better, or building back to only some people's better. This is where we as a design practice, we've been involved in participative design almost from our inception. And so we believe that participative design can offer some tools to remedy some of the critiques. So just a quick working definition of what we mean by participative design. It is an active collaboration of all the stakeholders in the design process. And it's predicated that the wider and active stakeholder group will bring knowledge, resources to co-create more appropriate responses. And specific to us, we want to focus on stakeholders who are most impacted and have the least agency. And that key one, which is that consultation is a passive approach, options A or B, whereas participation is an active involvement in the process. So I'm going to move on now to sort of show that in some active ways of how we have used participation in our projects. We're specifically focusing around housing. We're Oxford-based. It's one of our early housing images. And this is a list of some of the projects we've been doing. The kind of theme that runs throughout all of them is that they are creative responses to the housing crisis, and all of them contain varying aspects and different approaches to participation. So, for example, House of the Commons was a series of events that we ran, sort of big seminar events. Homemaker is a common theme. It's a 3-year research project, action research project entering year 3, which provides a common thread between all of them. Open House and Floyd's Row are the two I'm going to start to focus in more now. So Open House, this is what sometimes a buzzword used as an urban room. So this is an underused or an empty shop in a very kind of affluent street in Oxford. And this is repurposed for a 1-year project with a brief of creating an open and welcoming space for people who've perhaps not spoken before about different areas to come and discuss housing and the effect of the housing crisis upon them. So running workshops, talks, events, and on the most basic level, it offers a place for someone to come and drink a cup of tea who maybe experiencing the sharp end of the housing crisis. Some images of what was going on inside, some of the talks. What was sort of interesting as well here is that this, by embedding yourself more in this process, you start to tap in to the creativity and the resources that already exist within a city or within a community. So as a result of our experience here and the networks we gained, when Oxford City Council looked to build a new rough sleeper hub for it, we were approached to work with it. We did this in collaboration with Jesper Cook, another set of architects based in Oxford. Very briefly, it was to consolidate the services spread over the city with three key functions. For those of people who know Oxford, this was located in Christchurch, so right in the centre of the city. It was in a slightly austere sort of late 18th century building, despite being very central. It's actually quite remote or quite kind of hidden down a side street. And again, to Oxford City Council's credit, in the tender, we put forward to run a participative process. And this is something which actually they were willing to pay for and see as a huge value added for the scheme. So whilst we were working on work stages 1 to 3 with this participative approach, in parallel and in partnership, Jessup and Cook were doing work stage 4. We had a very tight turnaround in this project. So some of the sort of tools we kind of took out of our participant design toolbox was a rigorous analysis of the precedents, insight interviews with the stakeholders, in-depth brief development, so really taking the earlier findings and wrapping that inside of it. Two-way building tours where we're going around with people with lived experience of homelessness, lived experience of going through these kind of services, and them advising us on what they could see. So as much as them telling us as us saying, this is our design. And then followed up with multiple design workshops. Haven't got a huge amount of images from the design workshops due to sort of privacy issues. We took a very visual approach to it to make sure it was a very accessible process, particularly because some of the people we were working with had quite complex needs. And then from this kind of mess, or what you might see as very kind of lots of voices coming in, we then boiled this down into a work stage 2 report, which included design principles and really going through space by space brief development alongside an architectural design as well. So not going to go into all of them, but this is an example of when we were looking at one of the spaces for the somewhere space safe to stay, looking about all the things that were required in that space. And this was a direct result of the participation. So to translate those voices and those findings into a spatial outcome. And working through, so creating architectural drawings which have greater amount of kind of visual approachability to it. So again, something we can think about how we slightly change our tools to get them to a wider audience to improve the participation. And then slowly translating that further into something which is more recognizable as standard architecture, but it contains all of the aspects that we're looking through. Again, moving into the plan, kind of quite interesting there, you can see the number of sleeping spaces. So that's really for the severe winter emergency provision, when basically it's about fitting in as many bodies as possible during horrific or just bad cold weather. Again, this was finished off during COVID, so apologies, the images aren't always great, but this is an example of how we translated the need for the very welcoming and very clear entrance to the space. This is the internal space when you come in, a very kind of the view from, so actually the amount of natural observation from staff is very high. That's a direct result of what we understood from the users or people who lived experience, that they need this to feel safe. Following on for that, we looked very much at this idea about, again, it's not finished, we haven't all got the furnishes in there, but using second-hand furniture. So in this case, the lampshades, or moving through into also the kitchen areas as well. Again, more of this will be coming in, but a way that it meant that you can see something in here which looks like home or a home that you previously had. So making this a much more kind of approachable institution, much more along those lines of sort of a Maggie Centre, where you enter the heart of a building rather than being confronted by a desk. This is upstairs of the building, and then just finishing off on the outside of it. So that I focused then in on a individual building. Some of the other projects we're doing is also on a wider urban scale. And kind of coming back to that question is, can this improve the outcomes of the resilience projects? We would say particularly it's not a panacea, it's never going to solve all the problems, but particularly when it looks around the ideas of act as an agency, this is the area we believe it offers the greatest opportunity to make sure the most important voices are heard, and it releases the creativity in the project, something you're tapping into the inbuilt resilience and resources of networks and of communities already. It can't really help with a definition in terms of an academic sense, but it can certainly help us as a safeguard. I think much more like about this as the design brief, making sure you have a wider group of people involved means you're going to have a much more better defined brief. as was shown in the previous example. And again, the kind of political idea of who pays for it, the misappropriation, limited effect that it can have in that, because this is really where it nests into a wider political situation. But again, it does add some sort of safeguarding issues. So some of the much more projects which have been a real misappropriation of a term to push the costs onto one particular group, it offers some protection against that. So in terms of just closing thought, it's participation is similar to resilience in energy. It's prone to misinterpretation, and it can be co-opted. And if it's tokenistic, we think it should definitely be avoided because it may cause more harm than good. However, with the right expertise and processes, it can significantly improve the outcomes of the project and really mean that these resilience building projects have a much stronger base to move forward and will be more effective, in addition to being more just. So we'll move on to questions now. Otherwise, we love the message of participation and how we can distill and integrate it into our design project. So if you've got anything in mind, please get in touch with us. Otherwise, now I'd like to, in good participative manner, pass this back over to you for some questions.
Great, thank you so much, Alex. That was really good. It was a different angle for us. We're obviously doing a lot of work with engineers, planners, so it's good to kind of bring that architectural angle into the discussion. If anybody has any questions, please do raise your hand or pop your question in the chat window. I'm just having a scroll now to see if there's anything. Sophie, sorry, I've just seen you raise your hand. You have a question, please. Yeah, ask Alex.
Hi, yes. I was just wondering, because there's been a lot of focus on sort of collaboration due to COVID, and I was wondering if all that collaboration is going to take away funds from collaboration that could do with green design, or are you not going to see an effect, or is it going to be that they're going to have to work doubly together because they'll be tying in new technologies into buildings to mitigate COVID and viruses in the future?
So just to understand your question, is it the splitting of resources? So in terms of the resources required for participation?
Yeah, more. Yeah, are you going to see that? Do you think your resources will be affected because of what's going on, or do you think that they're more mutually exclusive things?
I think probably more like mutually beneficial. Because in the same way that if you kind of cast it in the light that we are going to be seeing a lot of projects at the moment in the name of resilience in this case to a pandemic, questioning or defining what the problems are and what the solutions should be, that yes, there may be some increased costs in the first place about running an effective process. However, in terms of the value for money, the amount of value you get from more effective responses, whereby that resilience building project will be more effective in the long run, it will be cheaper. So I would say that they're mutually beneficial rather than exclusive.
Okay, thank you. Yeah, that does. Thank you.
Great, thank you. Okay, we are coming up to 1 p.m. Alex, thank you so much for your presentation. If anybody does have any further questions, please pop them into the chat window and we can address them afterwards. We are coming up to 1 o'clock, so we are going to bring the webinar to a close.